We would like to present our final project. The name of our team is the Data Crunchers. The team is Kirubel and myself, Douglas. As you know, during all these weeks, our main focus was to use Microsoft Azure machine learning, and we was working different type of algorithms to discovering some structure, algorithms to predict some categories in the data, to predict some values. And this is our main focus in our project. We will use clustering algorithms, we will use two-class classification algorithms, multi-class classification algorithms, and also we will use regression algorithms to answer some of your questions. Then the main idea here for the clustering was try to discover the structure of the data set, and it was the German bank data set. We use k-mean, as I said before. The data set is 1,000 rows, 21 columns, and we want to answer and understand how many clustering groups are in the German bar data set. As you know, we was using Microsoft Azure machine, and we was able to use some columns in the data set, normalize to do some classifications, and we use the k-mean clustering. The main parameters was parameter range for the criteria triangle mode. We used the metric was the Euclidean 10,000 iteration. After to run that, we got this number of cluster. As you can see here, we have 0 to 6, 7 cluster. Using this algorithm, it was really good. Look, the distance is almost like the same. Then we have kind of a very good average distance to the clustering center. They are from 0.4 to 0.5.
Really, for 0.33 to 0.5?
And to answer the question, how many cluster groups are in the band data set, a good number should be 7. Now, using another type of algorithms to predict categories, we was using this particular one. We use 4 different types of multi-class classification algorithms. The idea was to identify some digit recognized coming in a kind of a file when we have 42,000 rows and 785 columns, and represent a pixel. Each row represent a number of pixels of the pictures, and we need to identify number from 0 to 9. We was able to create different cases for logic, to use logic regression, neural network, multi-class decision forests, and multi-class decision jungles algorithms. We use 7030. We got this. We got for this particular case, the best algorithm for multi-class classification was multi-class neural network with an overall accuracy of 0.97 and average accuracy of 0.99. Then to answer the question, each algorithm, which is the easy or the more accuracy number, or the difficult or the worst accuracy number to recognize, for multi-class logistic regression, number 1 was the easy one, or the better accuracy. With the less accuracy or worse accuracy was number 5. Sometimes here you can see the number 5. The algorithm got confused. I say there was number 3. For the neural network multi-class algorithms, the easy one to recognize was number 6. The worst case was number 3. For multi-class decision forest, the easy one was number 1, more accuracy number 1, less accuracy with number 3. For multi-class decision jungle, the easy one or the more accuracy was with number 0, while the worst accuracy was with number 5, where sometimes 9.2% of the cases where it was a number 5, they confused with number 3, and 4.5% of the cases where it was really a number 5, they confused with number 8. Now, what more we did in our project? We worked with another data set to work with the regression to try to predict some values. We use a dataset, Russian dataset. It has 30,471 rows, 292 columns. We try to use only 2, linear regression and neural regression. In this particular case, because the number of columns was a lot, 282, we tried to discard as much as we can and be able to work better, discard some of the information, some of the data. We try to, because we want to predict price, we try to work in a range of price that will be quite easy, more easy to work. We use some SQL transformation to discard some of the price of the house and was so high or so low, and be able to concentrate in the good data. Try to minimize the error or the noise creating for values that are or very very low or very very high. We normalize some of the data and we was able to compare these two algorithms. And here are our results. On the left side we have the distribution of the price. Here in the middle we have how is the mean absolute error for the linear regression and the neural regression. As you can see, it's almost like the same. Is better the linear regression for the mean absolute error, but the neural network regression has a better root mean square error. Of course, these values, every time we need to compare with what we want to predict, which values we want to predict, to understand that this is a good or no good prediction. In this case, I think so. Room to improve, but I would say that is quite good.
Well, really good.
This portion of our presentation will go over the German P1 dataset that we use. This dataset has 10,000 instances. It has 20 features, 7 are numerical, and 13 are categorical. I will quickly show how the dataset looks like, how we got it. We will be comparing 2 machine learning algorithms, 2-class logistics regression and 2-class-based cognition. We came to this decision by following the Azure machine learning cheat sheet, and we eventually decided that these 2 would be more appropriate for this kind of data set. Now I will show the Azure workspace. So basically, we first look at the data, and then we edited the data. We added columns. Column needs to be more descriptive. We edited the metadata, and in this time we changed some columns to categorical. And then we split the data to 70-30, 70% we applied an R script that applied bias to copy scenarios when we made a mistake. Mistake here is defined as a false negative. This is a scenario when we extended a loan to an individual that we should not have had. This will result in a default of the loan, basically. And this scenario is 5 times more costly than a scenario when we don't end up extending a loan to somebody we should have. So this is something that we will be cognizant of, and our models, in comparing our models, we will be more interested to minimize the more costly scenario, which is a false negative. So after applying the R script, we use the two machine learning algorithms. We train the models, and then we score them and we evaluate. I will show the results here. Visually, you can see both algorithms. One is blue, the first model is blue, the second model is red. And this is the breakdown of the results. So the false negatives for the first algorithm, the logistics, the two-class logistics regression, had 80 as false negatives, and false positives were 98. Comparing this to the two-class Bayes cognition, the false negatives went down considerably to 35. However, the false positives also went up. So this is a more conservative model. The AUC is very similar. However, in this case, as I mentioned earlier, since false negatives are much more costly than false positives, we believe that the two-class Bayes cognition actually performed better. So this data set was relatively simple and easy to follow, but it gave us a really good means to learn how to use Azure Machine Learning Studio, as well as get some hands-on experience running and comparing models.
Okay, thank you so much.